My name is Todd Toth, and I work at NASA's Goddard Space Flight Center. And basically, the project that I'm working on deals with coming up with a CO2 sensor that we could use within the GLOBE program to work along with the carbon cycle activities. And basically, we've come up with a number of different versions of this, which you can see in person at the Share-a-thon after this is over. The reason we're kind of looking at this, as I mentioned, we're trying, stand next to the closed here, to develop these CO2 sensors is, again, for the kind of a complete CO2 protocol. And in the process of this, I learned that we can come up with different types of sensors and sensor suites that include CO2, but also other things that have kind of gone by the board, like ozone and some other sensors that we can put into the sensor suite to make it kind of an all-in-one inclusive type sensor suite. Basically, why are we measuring CO2 and how can we do it? That's kind of the theme of my quick presentation here. And I'm just simply going to read some of the highlighted areas as you guys read the rest of this, but carbon dioxide warms the planet. CO2 also changes seasonal cycles and has a massive impact on photosynthesis through the seasons. It also creates some changes in precipitation. Storms are occurring more frequently and they're more severe. Many areas are receiving more rain or precipitation and are becoming wetter, while others are getting drier and drier. And one of the neat things I think about this is that working with a professor at the University of Maryland, I've come to understand the idea of carbon sequestration and the solutions involved in that. Very quickly, here's one of the sensors that we're really working hard on right now for schools in general and citizen scientists. It is a solar-powered CO2 sensor. Now, I say CO2 sensor, but it also measures temperature, pressure, relative humidity, and PM 2.5. Okay. We went through a series of developmental stages here until we finally came to the point that we were using too many batteries all the time. And then somebody had the stroke of genius saying, why don't we make a solar version of it? And that's where we are currently right now. That has worked very, very well for us. In fact, so much, we're actually working on getting the data from this sensor to a database through remote connections, through the internet, Wi-Fi, that type of thing. Okay? Just a quick representation of the data that we're currently playing around with here. This was started up last month here and ended up on, I believe, July 11th there, just to give you some representation of the data. But again, it is going from the sensor to the Wi-Fi to an in-between stage, so to speak, where the data is being checked by a Professor Ning Zhang at the University of Maryland, and we're looking at how accurate it is and the sensitivity of it, and then if down the road this works out, it will then be sent to the GLOBE database. This is just another slide quickly showing you some of the other pieces of data and how they'll be displayed. Again, kind of the same idea of what we currently have for when data is put into the GLOBE database. You see a push pin, and you can click on that, and it shows you where the data is coming from and what the actual data was. Very quickly, here are some of the other models that we're looking at that provide you more of a higher grade or higher research value data. This is one that I currently have on my back porch here from Professor Ning Zhang. The slide kind of got messed up. Uh-oh. Anyways, I'll move on. This is what it looks like on the back porch there. Some of the sensors involved inside of that. It is an all-season type sensor suite in that there is a heating pad in it and also fans to cool it down during the summer to keep it cool. All this connects automatically to the closest Wi-Fi signal to be sent out then. Just playing around with it, I kind of blew on the one sensor here, and the sensitivity of it is extremely good in that, you know, a second or so after I blew on the thing here, you can see the rise in the data here. And that screen also shows you a representation of what you would see on your, like your phone screen or a tablet screen. Also the, again, maps where you have your push pins to show your data. The only reason I'm kind of showing this one is that you can even pick up some things like the 4th of July fireworks and a change in the atmosphere there. I'll skip over this one right now. This was just one of well, the reason I included this is to show you how long that Professor Ning Zhang and I have been working together to come up with something for CO2. It started back in 2015. So he's got a large, large database of CO2 measurements for the Baltimore, Washington, D.C. area. Again, the network, this is really what we're honing in on right now, is coming up with a really, really good way or method of sending the data from the sensor to GLOBE. And we're simply calling it a smart network or the Internet of Things. But basically, uh-oh. Okay. Did I talk that long? Okay, here are the different versions. Long story short, okay, you can see these all at the Share-a-thon right after this. I'm done. I knew it, I just couldn't do it.